You can tell us after, because it's not going to take the entire class period. But I couldn't do that to you, Tanner.
What number should I do?
I like to pick on you, Tanner, but I'm not that evil.
Wait, are we not doing?
No, we're using our data. You started this. You were like, you make us do the same one over and over. So then we decided. Oh, it just makes pretty numbers. Okay. That was weird.
We're like over on class. Or Miss Mary just picked up the
Oh, you guys' data is so weird.
I think Chloe and I got this. Me too.
I'm gonna have to Google sheet it to actually get the R and the least squared regression line. I knew it for this data, but
It's telling me that circular dependency detected.
I don't even know what that means. That scares me. That's not a good sounding thing. All right. Gee, I don't want that. I'm sorry.
I'm just oh, okay. I'll just write it down.
I do type ultra fast. Seriously? We might have to go back to our real data then. Or I mean our fake data. The data I picked to make it nice.
What is that?
Say that again?
My eyes don't. It's 3.2.
And 3.9?
And then let's see. I want our trend line. See, I knew it was going to be negative. That just seems weird. B2. Oops, not period, comma. Might give me an R. It's a really bad one. It's almost 0, which means there is no linear relationship, which is kind of what we see. Honestly, it makes me think of the constellation Mr. Black is going to be so upset. I can't remember, but it's the guy with the, it's rounded and he's got like the bow. No?
Oh. It's not.
No?
I don't think so.
It's not Orion's belt. It's maybe if we add her data, it'll fix everything. What's your GPA, Amaranta?
Huh?
What's your GPA?
I don't know, 3.7 something?
Okay, and what's your ACT score?
Oh, I don't know. The 3.7 was 26.
Yeah, but we give that to
I
Isla.
don't know.
You're such a troublemaker. You show up late, and then you don't know your ACT score.
It was a long line in Chick-fil-A.
Gosh. 0.735.
Yes. Oh, really?
Chloe was being
There you go.
Tanner?
Uh-huh.
I have no idea. Look, I was trying to see what they were.
I'm going to sneeze again.
It's not bad,
Tanner,
but I did it.
you did it all?
Yeah.
Okay. Aw, that was so sweet.
I did mine on Chloe.
Seriously? Come on, computer. Why are you so slow?
Should I go to
Oh, I love that one. How's she liking Sal? She graduated. Oh, she just said. Yeah. So she was going to Sal and my friend volleyball, but she was over. She didn't have like any classes. So she
Okay, well, I'm going to get rid of her data because she doesn't know her ACT function.
She still like graduated on Sal. Yeah. It kind of sucks because she
You too.
All
right. So, we have our correlation, which is almost 0, which tells us that a linear relationship really doesn't describe this data, which you can kind of see there's no line. So we can continue with this data. I can't promise our residual plot will make a whole lot of sense, but we can see what happens. Or we can go back to my original data.
I feel like this gives notes, and I kind of like notes.
Okay, so let me put the actual data in really quick then.
Oh.
Oh, what? Yeah, we tried to do your thing, but I can't promise because it didn't have a linear relationship that it would actually work. So, and we want to make sure the data actually works. I'm sorry, okay? I do my best, Tanner.
What's the difference between an R and an R squared?
Oh,
R squared is the R squared.
Yeah. But we're going to talk very briefly about R squared today, and then we'll talk more in depth about it tomorrow. Uh-huh. You are so welcome. I love it when kids say that. It's so sweet. I handed out a test in Algebra 2 the other day, and kids are like, thank you. I'm like, you're welcome. I don't think you really mean it, but you're welcome. All right, so there's our data. There's our equation of our least squared regression line. So if you want to put that on your paper, we are going to use it today.
I was too lazy to look at my notes. I forgot how to get to the graph.
Hit second y equals, and it should be turned on. Yeah, so then hit zoom 9.
Ooh, I was even Zoom, but 8.
It's number 9. Uh-huh. Alright. I'm going to switch back to, oops, that's not what I wanted. There we go. Alright, so we have our least squared regression line. So today we're going to be talking about residuals. And I feel like I'm going to sneeze again. I'm sorry. No, I am vaccinated.
Yeah, Aiden's vaccinated.
With Aiden Vanderhoof.
Yeah. I like a week ago, I think.
Did, So on
I have to get vaccinated if I'm getting that word.
Friday, we defined residuals. They're the difference between your observed data and your predicted data. Using math symbols, that's y minus y hat. So the actual data minus our predicted data from our least squared regression line. So we're going to go through and we're going to find all the predicted. So it says, what would the least squared regression line predict for a GPA 3.0? So I'm going to put 3.0 in for x and find my y hat. So 11.5 times 3 plus a negative 15.1, which is 19.4. So my predicted is 19.4. You guys are going to go through and fill in all the predicted. The GPAs you're using are right there at the end of the question. And there's 7 of you and 5, so that means only 2 of you are not going to be called on to give me an answer. And I promise, Tanner, I will call on you.
Do I have to do all of them, or just the one you're gonna pick me out?
Well, do you know which one I'm going to call you on?
No.
Well, then I suggest all of them, just in case.
You're supposed to round up or round down?
Yes.
I have round down.
They only have 2 decimals. Why can't you just leave it with 2
Well,
decimals?
you can't get a
We're
decimal.
predicting. It's a prediction.
Oh.
Is it an actual song you're dancing to?
Say that again?
Is it an actual song?
We're in Sesame Street.
It's pretty good.
Sesame Street and the Scooby-Doo song. Those are my go-to songs. I never watched Sesame Street. My sister wouldn't let me. She was 5 years older than me. So what? By the time I was like 2, 3, she was 7 or 8, and she just I put on Sesame Street and she would not no Sesame Street.
Having older siblings completely skews it. It was on what you wanted to do.
I don't know. Henry owns the TV right now.
No,
We watch a lot of Coco Melon.
no. We're supposed to find the residual too.
Nope. Just the predicted.
One time, my brother was watching Family Guy. One time, and I came home, and my mom was like, "Turn that off." And then
What
I
was
told
you watching?
Family Guy.
I was.
And I told my whole family that I watched Family Guy. And my mom was like, "She does not watch Family Guy." Yeah, it was
How old were you? Oh. No wonder she didn't want you telling people that. All right, let's start with Joanna. What's the predicted one here?
25.15.
Thank you. Isla, next one.
20.55.
Thank you. Tanner.
30.
Thank you, sir. So, what's the predicted for a GPA 3.7?
Oh, like 27.45.
Thank you. And Chloe.
20.55.
Thank you. All right, and then the actual, that's just copying the data down from our table up here. actual GPA for 3.0 was 19, and then 27, 22, 31, 26, and 19. And then the residual, you're going to take the observed, or your actual ACT score, minus the predicted. So for this first one, we're going to take 19 minus 19.4, which gives us negative 0.4. You guys are going to find the other residuals. Actual minus predicted. Sorry. I have way too much energy right now. Oh, I got smaller. She used to have the $100 bill and now it's only 50.
Oh, boy.
Oh yes, you have to get gas. Their gases are so much money.
No, I paid for my parents' like mulch and irrigation system yesterday at Lowe's.
Well, that was nice of you. Trying to cover it up. I'm calling on you again.
You never catch me sleeping.
I can call you out on that right now.
Oh, we have my correct case.
Go.
Alright.
What is that?
Death quiz.
From
Yeah,
what?
these laying around.
Of course I have
What
one
is
of those
this,
laying
like
around.
math 7?
What does that even mean? That makes sense.
If 5 times 6 plus 7. That's 2 of the questions. Or
Oh, that is. That's my death quiz. Actually, I want to see if you can do that. That was Algebra 1B, sorry.
That's what they do in Algebra 1B. I should take that.
At the very beginning.
Is it easy?
Makes me fall asleep, it's so easy. Alright, I left off at Chloe, so Emma, what's our residual here?
1.85.
Thank you. Amaranta?
8.55. No. Oh, I got that wrong. I just put the,
That one minus that one.
so it's 1.4.
Thank you. And then Joanna?
0.1.
Thank you. Sorry, my brain was thinking negative, but that one's not negative. Isla?
Negative 1.45.
Thank you. And Tanner?
negative 1.45. Wait, girl. Someone got something wrong.
You.
5.
There we go.
Wait, why? Am I like choosing really hard right now?
19 minus 20.55.
Oh,
You are tripping hard.
Except for wait, you got the answer right.
Yeah, but he had 4 or 5 on his paper.
You got the 5 times though, eventually.
Because you noticed that Isla said negative 1.45 there, and he was like, wait a minute, that's not the same as mine. So, now we're going to make a residual plot. So, residual plots, it's going to be at the bottom, that's why I left all that space. Residual plots tell you a lot about your linear relationship, which is why I wasn't sure that keeping with the actual GPA ACT data would help us. So with residual plots, you're going to graph your residuals with the GPA data. So we're going to have our residuals on the Y, and our GPA is still the X. Now we have both positive and negative GPAs, which is why I put X through the middle, or not GPAs, excuse me, residuals. So GPA, that's not going to change any. It still goes to a 4.0. That's our origin there. And then our biggest residual is 1.85 and negative 1.55. So I'm going to go 2 to negative 2. And then we're just going to make a scatter plot. So we take our GPA, 3.0, and the residual, negative 0.4. So GPA of 3 has a residual of negative 0.4, so about there-ish. 3.5 has a residual of 1.85, so up there somewhere. 3.1 with 1.45. 4.0 with 0.1, so that's like on the X almost. And then we have 3.7 with a negative 1.45. And then 3.1 with a negative 1.55. So there's our plot. Now, I'm going to show you how to do it on Google Sheets. I personally, if it's that small amount of data, I actually find it just as simple to do it by hand. But I am going to show you Google Sheets. And then Joanna, I'll show you on the calculator in a minute. Can I switch? Alright, I don't need that. So, you don't have to put a title. I'm going to put predicted ACT. You could put Y hat, whatever you want. I'm going to put that so that I know it's my predicted. So then I'm going to highlight the cells. Notice it matches the same amount of cells for the GPA ACT data. And then I'm going to go up here into the formula bar, and I'm going to put equals, and then I'm going to type in our least squared regression line equation, so 11.5, and that's going to be multiplied by x. Well, my x values are in these cells from A2 to A7. And then we're going to add our y-intercept. So I put plus negative 15.1. And then I hit enter, and it gives me 19.4, which remember was our predicted ACT. Then I'm going to just highlight that single cell and drop down the corner, and it fills in all my predicted ACTs. Questions before I move on? No? Are we good to move on? So then my next column, I'm going to call residuals. And I'm going to highlight, go into my formula bar. And residuals are your actual data minus your predicted data. So my actual ACT scores are in B2 to B7, and I'm going to subtract the C2 to C7 range. And then I'm going to hit enter, and it gives me my residual for that first one. Highlight it, and then pull down and it'll fill in the rest. I don't know why it won't fill them all in at once, but it only does one, and then you bring it down. Good so far? And then we want to make our residual plot, which is the GPA and the residuals. So I'm going to highlight my GPA, and then I'm going to hold Control down and highlight my residual column. And then I can go to Insert, Chart. Now it shows a column chart, so we want to go to the chart type, scroll down and choose Scatter. And then it, for whatever reason, defaults to putting two sets of dots. So the blue dots are GPA and the red dots are residuals. We don't want that. So what we got to do in the setup is we go to the x-axis, click Add x-axis, and we want that to be GPA. And then under series, you notice it has both variables. You want to remove GPA from the series. And now we have our residual plot. But first, I'm going to go in and mess with my horizontal axes. So it starts at 0 and ends at 4. Oops. Horizontal. There we go. And there's our dots, just like we did by hand. Okay? So you can do it in Google Sheets. Like I said, when it's 6 points, I honestly don't think that it's easier to make it here than it is to make it by hand. If it was 20 points, I'd probably use Google Sheets. But those 6 points wasn't hard. Questions before I move on? No. No. Chloe's looking at me funny. All right. So now we're gonna, I did know we're still on the first page. The rest is gonna go quick. First page was the most important. So, how do we get a good idea on average how far off our least squared regression line is in predicting ACT scores? So just a cool little fact, the average of all the residuals is 0. If it's not 0, then you did something wrong. But to me, it's kind of like a built-in check. And actually, you can say the sum of all the residuals, because for your average to be 0, the top has to be 0, which is where you add all the residuals together. Standard deviation of the residuals, S. You're not going to ever have to use the formula. I just want you to know how it's found. The only thing you're going to have to do is interpret S when I give you S or it's given in the problem. But the way they find S is they square the residuals, add them together, divide by 2 less than the number of data points, and then square root it. So we could find it for this data, but like I said, I'm never going to have you find S. You only have to interpret S. So for the GPA ACT data, S is 1.58. Now when it comes to interpreting, kind of like with slope and y-intercept, I'm going to give you like a sentence frame, and then you only have to change a few things depending on how the problem changes. So the way I do it is I say, when using the least squared regression line, the average error in predicting ACT scores from GPA is 1.58 points. So ACT scores, GPA, and then the actual value of S, those are really the only things that would change, and the rest you could use. When it comes to residual plots, there are certain things you want to look for. You want the residual plot to be scattered evenly above and below 0, and that tells you your least squared regression line is a good fit. So if we look at our residual plot, we had 1, 2, 3 dots above 0 and 1, 2, 3 below. So they were evenly scattered above and below 0. So our least squared regression line is a good fit to our data of GPA and ACT scores. If the residual plot is curved, the least squared regression line is not a good fit. A curve is a bad thing. And I promise you, on your test, I will throw a curved residual plot at you to see if you were listening to me today.
Not a good fit.
It's not a good fit. You want to look for residuals that increase as x increases. And if you have a large residual, that means you have an outlier. Now, large is a subjective word.
You draw this weird aspect.
What's weird about my S?
What have you drawn?
Top to bottom?
Oh,
Oh, the asterisk. Yeah, I don't pick up my pen. But it's this thing. I just don't pick up my pen.
Oh, okay. I thought I was just trying to draw like a big T with like a bow.
Sorry.
So it takes me some time to draw it.
Can I see if you got
Here's my first
Wait, how do you?
one. I just didn't know.
Okay.
These ones are better.
I don't, my hand's going to be in the way the entire time I draw it. Now all I'm going to be thinking about is how to
No,
draw
I
it.
can't draw mine.
I know, seriously. I'm like, I really can't. I can't remember how to do it.
I always start with an
That doesn't look like it. I don't know. So my mom, she's a Karen. Literally, that's her name. And growing up, I never got her signature. That's her K. Right. I was like, so when I was like, how do I forge this? Like, but it like I get it now. Like if you cover up the big loop, it is a K.
Yeah.
But it took me forever to realize. I was like, what is this huge loop she's got going on?
That's her T. That's her T. What's your mom say? I think your mom would be a mom.
I know. My mom and my signature are almost the exact same.
My dad and I have very similar signatures, which is weird because our handwriting is nothing alike. But our signatures are close. My mom and I have similar handwriting.
My mom, I feel like that's signature. I feel like I do most of my signatures except for my mom.
Oh, we're doing
My
another
mom's
stage.
just like fancy. Yeah. Maybe my grandma's. No way. It's like small. Aw.
Residual plots should have absolutely no pattern. If they have a pattern, that's bad. No pattern is good. How weird is that? math, we're usually like, where's the pattern? We need to find the pattern. We don't want patterns with these. May I flip? Thank you. So last time we didn't get to it. I had some of this on there, I added to it. The biggest thing is this down here. This is a software output that gives you data on the regression relationship. So I want to teach you how to read it. So we're looking at a random sample of 15 high school students that were selected from the U.S. Census at School database. The foot length in centimeters and height in centimeters of each student in the sample were recorded. Least squares regression was performed on the data. A scatter plot with the regression line added, that's this one, so a scatter plot with our regression line. A residual plot, that's this one, and then some computer output from the regression are shown below. So A says, what is the equation of the least squared regression line for predicting height from foot length? It should say use the equation, not us the equation. Use the equation to predict the height of a student with foot length of 27 centimeters. So to get our equation, if we look at this column right here in the computer output, it gives us our slope and our y-intercept. So to the left, it says constant. Well, between your slope and your y-intercept, the y-intercept is the constant. So this one's our y-intercept, 103.41. This one is our slope, and it's being multiplied by foot length to predict height. So then we have all the information we need to write our LSRL. Y hat equals 103.41 plus 2.7469 times x. Foot length is the variable that is specific to this question. So that wording will change. Constant will always say constant. So if you know constant means your y-intercept, doesn't matter what the variable is, that one's your slope. So then we're going to use our equation to predict height for somebody who has a foot length of 27 centimeters. So we're going to put 27 in for x and see what we get. .7469 times 27 plus 103.41. So we get 177.5763 centimeters. Oops, 177. Not right. Questions on that one? So B says, what percent of variation of height is accounted for by the straight line relationship with foot length? Anytime you see this phrase, percent of variation, that's them asking you for R squared. And like I said earlier, we'll go more in depth with R squared tomorrow. But that's what they are asking for. They'll never just straight out ask for R squared. I don't know why. They always ask for percent of variation. So to looking at our computer output, down at the bottom, that's hard to read, it says S. Then we have R squared and R squared adjusted. Don't ever use R squared adjusted. We don't use it at this level of statistics. So our answer to B is right here, 48.6%. No math to do, it's just right there. By the way, I'm going to jump back to Google Sheets really quick, because I noticed the other day when you tell Google Sheets to put, oh, of course it's not going to do it. Well, this isn't, we'll see. When you go into series and you tell it to put the trend line, and then you go down here and tell it to put the equation, right here it says show r squared, and so then it would tell you r squared up here. And right now it says 0 because this is our residual plot, not our actual scatter plot, so there's no linear relationship. So that's why it says. But you can get your r squared value in Google Sheets pretty easily. And then C says use the information to find the correlation R between height and foot length. And how do you know whether the sign of R is positive or negative? So if I have R squared, how do I find R? Square root it. R squared, square rooted would give me R. Now, before you just do that, you do need to turn this into a decimal. Otherwise, you're not going to get the right answer. I don't think. Pretty sure. Because decimals, when you multiply bigger decimals together, you get smaller decimals. But if we square root 48.6, we'll get a smaller number. Because they're in inverse relationship. So you want to square root 0.486. And you get 0.697 for R. Although, I suppose if you screw up, you could just move the decimal one to the left. Because square root of 100 is 10. So it kind of does give you the same answer. I just know in the past kids would give me this answer when that's the correct answer, so I always tell them to change it to a decimal first. And then remember, anytime you take a square root, you have a positive root and a negative root. So how do I know if this is positive 0.697 or negative 0.697? The slope. You can either look at your actual slope, which is positive, or you can look at the line, which is positive. So our R would be positive. So that's our final answer there. And then D, this I had on there last time because I wanted to introduce S a little early, but we didn't get to it. So it was interpret S in this setting. So it's hard to see. It's this one down here. S is equal to 7.95126. And so when we interpret, it's going to be very similar to like what we did on the last page, but instead of ACT scores and GPA, it'll be foot length and height. So we're going to say when using the least squared regression line, the average error in predicting, we're predicting height from foot length. And I'm going to abbreviate foot. And then I do have to put the right label. So with the ACT scores, we said 1.58 points. Here, our average error is measured in centimeters because that's what height is measured questions? Alright, so the bottom is an exit task. I want you to make the residual thought, interpret us. I'll come around, hand out homework. Tanner can tell us his story.